Hi guys, welcome to Techogenius Academy. We are de-industry-led training providers for those who wants to build their career in data science, analysis, IoT, device driver, embedded Linux and many more. Please do like, share and subscribe to our channel.
Hello everyone, I am Akshara Shrivastava from Techogenius Academy. Let's continue the session of NLP basic concepts. So now let's go to the next section of it, which is the text cleaning part. Okay, so before creating any features, okay, whether it's a normal machine learning model also, right? So before passing any feature into that, so we need to understand what features are going to be important for deriving any insight out of it. So some, because this is a human generated text, right, so it might contain a lot of information which is not at all important for deriving any insight. So it's useful that we have to adopt based on the data that you are handling. We have to apply a couple of the text cleaning activities. So these are the very basic and the generic text cleaning activities that I have listed it out here before doing any feature engineering part on top of it. So it's like the text can be written in any cases, right? It's can be uppercase, lowercase, and something like that. So we don't want that uppercase word or the lowercase word should depict the different meaning, although it is same, right? So in this way, we can normalize the words. So we just uh, convert everything into a lowercase. Then the punctuation sometimes don't contribute much, so we can remove that as well. Then same thing with the numbers. If you the numbers are not very important for your use case, you can remove that. uh, then if sometimes your text contains a lot of white spaces, blank spaces, so you can just remove it that as well. Then there are special characters as well, sometimes you can remove that. Some emojis, hashtags are also there, special words are also there. If that is not contributing into your uh, uh, thing that you wanted to analyze, so you can simply remove that. And then this replacing contractions with their expansions. Okay, so this contractions means sometimes we say something or write something like I haven't done this. Okay, so that haven't, so you can expand. I don't want that haven't and have not should be interpreted differently. So it's a good idea that what wherever the contractions, that these kind of words are there, you just expand it into their original forms, so that it should be comparable. So but we need to understand like how, what kind of a data that we are handling, and based on that only we have to apply text cleaning. It is not mandatory that you have to have apply all these text cleaning, no, because sometimes these special word emojis and punctuations, right, that is actually going to add importance into your feature generation. Because there, what happens, some of the steps might not be suitable, right, for particular steps. So when you are getting the sentiments correct, so these punctuation and word marks, so these creates your emojis. Okay, so you can't process that emoji because that emoji is going to tell you the uh, emotion of a person. It is going to identify what's a person's emotion or sentiment it is. So if you are going to remove it, you're not going to understand what that text is all about, right? So based on our text and based on our requirement, we have to apply the text cleaning. So whatever I have discussed here, I simply created a simple small functions out of it. So these are the very basic one, like text lower. Here I've created and removed punctuations. Okay, so I have imported these many libraries which are going to handle all the steps that I have covered over here. Lower punctuations, remove the numbers and white spaces, HTML. Sometimes HTML markups are also there, right? You can remove it, and yeah, contractions as I discussed. So this These you can call based on your requirement. Let me execute that. So let me do one thing. So this is my data, right? So let me take first text. Okay, that is your first row. So this is your row, and let's apply um, all the text cleaning one by one. Yeah. Yeah, so this is my first row, and I'm just trying to remove the punctuations. So let's see how it looks like. So this is your previous data, like original data, and this is after removing the punctuations. So if you can see, these things are gone, right? And then you have the punctuations. In punctuations you have full stop, these hyphens, these are actually gone. So this way your this punctuation works. Now let's move on to the other one, the lowercase. See, the very first one also got converted into the smaller case here. Everywhere I got, you know, mm, changed. Alice here also it got converted into the lowercase. So this is how you can, make it into the same case. Okay, I think I have done remove punctuation 2 times. Let me remove that. Then remove numbers. Okay, see, here we do have this 39 something, right? So now we are not getting any 39 over here. Yeah, maximum 5 days. So now 5 is gone over here. So that is what we need to understand, whether that numbers are important for our analysis or not. So if it is an important, then you need not to, execute this one. Then we can remove the white spaces. Let me see whether we do have any white spaces are there. Okay, so white spaces means if there are multiple spaces instead of only one space, if you have multiple spaces in between, right? So this will basically remove that multiple spaces and just keep the one space within two words. Yeah. And this HTML, this I don't think so there are any HTML tags. So maybe I can show you how it works. Okay. HTML tags. So here in this one you have to provide any text, right? Hello, this is the head, sorry, this is the head of your HTML block. Yeah, so if you can see here, we have this head only, but since it is a HTML tag, so it got removed. Yeah, okay, fine. Here this last one, replace contractions. So I don't think so again any contracted word are there, but I will show you how it works again with the our own example. So I hmm, okay, so that is a catch here, so we should just use these brackets. I have not visited that place. Yeah, okay, okay, sorry, I have given the wrong thing. So see, this haven't is just expanded into have not. So that we can normalize our text. So somewhere if have not is explicitly mentioned, then if you are not applying this contraction, so haven't and have not, the machine uh, uh, interprets it differently, not the same thing, right? So this is where you can use that. Then let's go to the next topic, which is the tokenization. Okay, So this is the next, again, the very useful step of a kind of a useful pre-processing step on which other steps are dependent, right? So this tokenization is, as you understood the word token. Token means a chunk, right? So it is a process of dividing your large text into the smaller chunks. So text can be divided into the sentences, and they can further divide into their different words. So we are going to use the NLTK uh, package for this, okay? In order to understand a couple of the steps. So NLTK we are going to use, which is a natural language toolkit. NLTK means natural language toolkit, and it is one of the best and well known and mostly used NLP libraries in our Python ecosystem. And it is useful for all sort of tasks like tokenization and stemming, part of a speech, which I'm going to cover a little later, and more any like other activities, for other activities as well. Yeah. So let me start with this thing. So I have imported this from this NLTK package. I have imported this word tokenizer. It is going to tokenize this entire text. So this is the given text, and this is a method that you can apply, word tokenize, and provide this text. So let me quickly execute it. Yeah. So now you can see here how the entire text can be, split it into single words. So first tutorial on these are the different words. So this is how this word tokenize your words. And then, as I mentioned, not only you can tokenize your words but also the text. So also the into the sentences. So if you have a large piece of text, so the good idea is first to uh, split the entire text into different sentences, and within that sentence then apply this word tokenize. So suppose this is the text that I'm going to use. Okay, this is the first tutorial on NLP. The second text is next tutorial are coming soon. Okay, and same thing, same package, I'm applying it, but this method is different. Send tokenize is there. Just execute it. See, this is the first tutorial on NLP. This is your first token, which is your sentence, and this is your second sentence. Yeah, in this way you can split your text data. So there are other tokenization method as well. So if you can see here within that NLTK tokenize only, there are other also, like using regular expressions. You can, split your entire sentence into the words. Okay, using the punctuations or using the blank line. Okay, so suppose I do have this text. Okay, so it is going to perform all the three different types of tokenization. Okay, so the first is it is going to do the regular expression. I have given, like, you just split the text based on this regular expression. Okay, need not to split on every spaces, like here it was doing. Just split your text on based if it is following this pattern. Yeah, that is your regular expression tokenize. Then using word punctuation, and then if there is a blank line, so there, that is why I've given this blank line thing. Let me execute it. See, so now here it is tokenizing it based on your thing, whatever it has given over here. Yeah, and then here it is doing it using the punctuation. Just see the difference. Here it is considering this as your one word or a one token, because we have given this thing over here in our pattern. But since it's the punctuation one, so what it is doing, it is just considering everything as a different tokens. So that is what we need to identify, like which one is better for our purpose. And then it is a blank, like line tokenization, right? So wherever you have a blank line, just split that thing. So this is how it is happening. So blank line is, if you see here, we do have over here. So this is by blank line, our next line. So this is how it is splitting it up. Yeah. So then we do have another set of tokenizer using a tree bank. So basically tree bank is a parse text corpus that annotate syntactic or semantic sentences structure. So we have again imported the tokenizer and detokenizer also. So once you tokenize a sentence, if you wanted to, club all the tokens together into a proper statement, that also you can do here. So if you see here, I have given one text over here, and I've created a instance of your detokenizer and tokenizer, and then these are then I'm calling this tokenize on this sentence s, and I'm just printing it out whatever what is the original sentence, which is tokens, right? Detokenize is going to be done by this detokenize method, and then using a detokenizing using certain split thing. Okay, let's do that. Yeah, so your original sentence, okay, got tokenized something like this. Okay, and in detokenize all the tokens get clubbed together and it forms your sentence. Yeah, and here in detokenize you can pass like how you wanted it to be detokenized thing. Okay, so it is like create a different sentences based on your space. Yeah, so wherever it finds some space, it's create a different sentences. So this is the another step, and then we can write our custom definition. So it is like a definition and you are just calling it. So now since till now here I was executing it on a single statement, so now you wanted it to execute on your given data set that we were working on, that is your review data. So that is why I have created one function simply, and I'm just putting an apply function which applies this custom tokens on each and every rows of the data set. So this is the way it works. I will show you how it looks. So I created a different column as well, custom token. So see, till here we were having our original data, and now we have created the custom tokens. Yeah. So here it is getting stored in a list. So this is how you can work. So let's continue the basic session, starting with the stop words. So now what is stop words? So stop words are the words in the text which do not contribute much in categorizing to document from each other, because they are very common occurring words. So I will show you what kind of stop words are available. So different NLP based libraries provide you the stop word list that you can use directly use, and you can customize it also. So let me show you again. Same, we are going to use NLTK, and from here we are importing the stop word which is of English language. So let's do that, and let's see what you get in that list. First of all, I want to show you what is the type of that. So just see what the type it is. It is of list, right? um, Now just see. So stop word contains these words. So as I rightly mentioned, so we don't want such words into our vocabulary or into our analysis which do not contribute much into our into making any decision or into segregating two documents, right? So these are the words which are like common occurring words that doesn't differentiate two documents. So it is better that you can remove these words from your text. Apart from removing the words from here, you can also add couple of new words which is not available here, which you want to remove it from your text. So here what I have done it, like some of the words which I do not want to be available into my text, so I just wanted these words to be just get appended into this stop word list. So when I'm going to execute removing of stop word method, it is going to remove it from my text. So simply you can just use the append uh, function of your list. It is going to append it like new like. I have added it. If you can just see and search is new like, you might be able to see somewhere. Mm, yeah, you can see new has been now added into your stop word list. Same way, same way you have added your new words. Like sometimes if you want to remove some of the words from this stop word list, means you do not want that these words should get removed from your text. You want those words into your text. So suppose in this stop word, right, I have this because. Okay, so I am thinking that because is an important word for a differentiation. Let's assume that. So you can do the same thing like this. Yeah. And let's see whether are you able to see the because word over here. See, it is not here. Yeah. So in this way, you can customize your stop word list, whatever you want in your text to be there and what you do not. Right. So now let's see how this is going to work. So this is a word tokenize method that I have taken, and I'm just passing the sentence S. So let me just see what is there in S. Yeah, we do have this, right? So in this one, okay, this is a tokenized word. So it is going to create a token, and then we are applying this stop word removal using this list comprehension. So what I'm doing for every word in your text token in your this, okay, if that word is there, sorry, if that word is not in your stop word list, then consider it, otherwise remove that. Yeah. So if you see off, here we were having off and in. So off and in were there in our stop word list. So this function has removed off and in because they are not much contributing to our text. Yeah. So till now we were talking about NLTK. So there is another popular libraries, which is Spacy, which we will deep dive into our subsequent session. But I just wanted to show you that library also has their own stop word list, right? You can see here. So these are the stop words. So you can compare and contrast what all stop words were there in NLTK and whatever is there in your Spacy. So you have to load the model and then execute this default stop words available. So you just have a look on it. Okay, so now in order to apply this stop word removal into our data that we were handling for the reviews, patient reviews, I again created a function for it. It is same as say same list comprehension. I have taken it but put in kept it in a function. If you see here, my data stop word token is equal to my data. This is a custom token that I have because you know, right, stop word works on the tokenized data. So already we have this column custom token that we created during the tokenization step. So just apply this stop word removal and let's see, we have is, right, it is now removed. 2 that has also been removed. So this is a way by which you can remove the unnecessary word which is not very much contributing in the context. Yeah. Okay, now let's move on to the next technique. So the next technique is your stemming and lemmatization. So what happens sometimes we do not require all the form of words like past tense, present and the future. We just want to know the base word of it. So example, we have play, playing and played, right? All three refers to the base word play. So we are only going to be interested in that, like in some search engine, it doesn't require all forms. So we need to chop the words into its original or base form. So it just need base form in order to search anything. It doesn't need all the forms to be present in your vocabulary. Yeah. So lemmatization and stemming actually does this job for us. So if you can see, we have this is a normalization techniques because we are normalizing the word into their base form, and it is putting it into their canonical ones. And as I mentioned, it is going to be used in the search engines. So now, what is the difference between the stemming and lemmatization? So the main difference is that stemming, it works basically on a single word, and it doesn't consider the context of that word. Okay, like in what context that word has been used. In despite of that, it just simply takes one word and then chop the ending of that word. If we have playing, so it remove ing. If we have does, it remove es at the end. So without understand like a previous understanding, like in what context we used it, it doesn't consider that. So, and the other thing is, since it is not doing that calculation how a word is used being used in the context, so it is a little bit faster as compared to the uh, lemmatization. So again, here also we need to understand like which one is best for our use case, for our sort of data. So these are the following different types of the stemmers that are available: Porter stemmers, Snowball, um, Lancaster, and regex. Yeah. So these are the main features of each stemmers, like which one is does what. So here, if you see, it is a very aggressive one. So it is, then Snowball is the improvement over the Porter. Okay, and it is computationally heavy actually. So this one is faster as compared to this one. And Lancaster is a very kind of not very intuitive. So it is an aggressive one. It simply remove the last word. So you will get very shorter word, which is a bit confusing. You won't be able to understand what that word means sometimes. So it reduces your word, which doesn't good for our vocabulary generation. Yeah. So the best for now we can consider it's like a Snowball, and also sometimes we use a Porter. So, and regex expression also. So you can also provide your regular expression in order to stem your words. What do you want to be considered while stemming the words to come up into your base form. So if you see here, I have given you an example between the lemmatization and stemming, how it is doing it. So was, studies, and studying. So see how stemming is simply chopping off the last word s, es, ing. But on contrast, lemmatization is maintaining the context as well. So this is let's see how it can be implemented in Python. So I'm showing you all the examples for the stemmer, all the portals, Snowball, Lancasters, and regex. Yeah, and this is the text on which we are going to apply the stemming. And these are the different instances that we have created. And then simply again it also works on the tokens, right? So again, a list comprehension in order to apply the stemmers, different stemmers on tokens. So let's execute it. Now here you can simply see the differences between the different stemmers. So as I mentioned, like Asters, how it does, right? Simply just like got reduced to like I like it, which doesn't make any sense, right? So in this way, that's why it is kind of reducing your words. Then Snowball and Porter, if you see here, yeah, this is more or less giving you the similar result. But if you see here how it has, uh, maintaining the word meanings as well. It is giving you has, but it is like etchy. So then the next one is the regex, as I mentioned here. If you see in regex, while creating the regex, I'm saying that whatever the word ending with ing, just put it into their base form. Just remove ing there. Okay. So in the text we have eating, right? So here simply it removes. It simply keeps the eat. So in this way you can also generate your own stemmer if it is very much particular to your data set. Then this is the lemmatization. So if you see here in lemmatization, so in lemmatization I have taken again from the NLTK library net lemmatizer. It is also doing the same way using the list comprehension, worked on these tokens and get the lemma of each words. So this is the output that you can see, and just you can compare it with your stemmer, how different it is from the different stemmers that we have seen. So here you can see apple we have got chopped off into APPL. So E has been removed from here, but here we do have a proper word apple, because looking at the context of the sentences, it is maintaining the proper word. So this is how your stemming and lemmatization differs while creating the base words of the different forms of word. Yes. Now let's apply lemmatization on our review data that we were having. So same, I'll uh, uh, use the apply function and just use the lemma using the list comprehension. Let me just quickly see how it looks like. Yeah, lemmatized token. So here it is. This is the thing that you can see here. So we have to cover the other topics as well. So I'll cover the rest of the topics into our next video. Till then, stay tuned and please do like, share, and subscribe to the video.